Hello everyone, my name is Oleh. Today I am going to present my project using machine learning for credit score prediction. The goal of this project is to compare the accuracy and precision of models for different setup of input parameters. This time we focus on dataset generation and its preparation for machine learning. Training models and evaluation them on the prepared dataset will be the task for the next capstone. This slide introduces the credit score, which is a number representation a person's financial reliability. Scores typically range from 300 to 850, where a higher score means lower risk for lenders. Credit scores are used by bank and fintech companies to decide loan approvals, credit limits, and interest rates. The main factors are payment history, looks at whether you are paid your bills on time. Credit utilization measures how much of your available credit you are using. Loans of history consider how long your account have been opened. Type of credit accounts looks at the mix of loans, credit cards, and other accounts, and recent credit inquiries. The factors together determine how reliable and borrower in the eyes of lenders. Since real financial data is often confidential, I generated a synthetic data set for model training. The parameters were generated randomly, with some peculiarities that we will discuss later. During credit score calculation, almost all features are simply taken into account as coefficients, except for days late. Let's focus on this one in more details. Depending on the number of days a payment is late, the person receives a penalty. Moreover, a paid-off late payment still affects the credit score. In this simulation, its influence continues to decrease over the next 3 months. After data generation, a quick check of feature distribution was performed. The goal was to see how often different parameter values occur in dataset. The code and part of the output are shown. For the days late parameter, an additional bar chart was created to visualize the distribution across year. To get some insight from the data, line charts were created to show the average debt and average credit utilization in the dataset. Overall, the average debt shows a gradual decrease. However, in 2020, a sharp spike is observed in both debt and credit utilization. Okay, insight from the charts. The general trend indicates a reduction in client's debt level over time. The anomaly in 2020 may be linked to external factors, for example, some economic impact of the pandemic. The simultaneous spike in debt and credit utilization suggests a correlation between these factors. This correlation requires additional investigation. Actually, the anomaly in 2020 was intentionally introduced during data generation to make the dataset more interesting, but it could also represent unusual conditions in real scenarios. As expected, the average credit score generally increases over time, except for 2020. This trend is clearly visible in the chart. This slide presents the dataset after credit score calculation. To illustrate the impact of overdue payments, two additional columns were added. Column score, calculated without considering overdue payments, and score final, calculated taking overdue payments into account. Also added columns days late 1, 2, and 3. They present overdue in previous months, 2 months ago and 3 months ago, respectively. Additional column previous score was added to the dataset just for future model learning. It shows the credit score calculated in previous months. Just as an example, we can observe how 60 days overdue affects the credit score for up to 3 months afterwards. Here an overdue happened, and we can observe this overdue for the next 3 months. The next stage of the project will involve training model using the prepared dataset. Model 1 will use the initial set of features. Expected performance, relatively low accuracy and precision, since the dataset contains limited information about previous overdue events. Model 2 will additionally include fields days late 1, 2, and 3. Expected performance, much higher accuracy and precision, and this feature directly capture overdue behavior. And the most interesting, model 3. It will use the alternative set of features including without days late, but including previous scores which already reflect information about past overdue. Expected performance in this case higher than better accuracy and precision comparing with model 1, but the most interesting part to compare accuracy and precision between model 2 and model 3. Thank you all for your attention. I appreciate your time and interest in this project.